friends. Today we're going to be going over basic functions, so kind of a continuation of what we started last class. I'm actually going to start off by reviewing the quadratics or parabolas and what we did with them. Then we're going to move on to square root functions. After square roots, we're going to do cube functions, cube roots, and then absolute value. And those are going to be our 5 basic functions that we're going to be really familiar with how to graph them and how to apply transformations to them. And it's just going to make our lives really nice and easy. So last class we learned about parabolas. Their base function is x squared, and we can make a table off of that by just doing values like -2, -1, 0, 1, 2, and then we plug them in. A parabola's U-shape has a nice vertex. That vertex can only be moved by translations. It's nice and symmetric. It has a domain of all real numbers, and its range is going to be 0 and above until we shift it and apply transformations. We had a little shortcut that we talked about where we would find the vertex using the translations, and then we would go over 1 and then up 1 squared because it's x squared. Over 2, we'd go up 2 squared. Over 3, we'd go up 3 squared. That was our shortcut. The real way that we would do this is we take our base table, so the y equals x squared table, and we apply our transformations to it. All right, so anything that's affecting the x values, we would do that to the x values. So we take the original x values of the table and we would add 2 to them for this one. Same idea with the y values. Anything that's outside affects y. We take anything from the original y values and we would subtract 4 for it. Down here, we would do -2 times all of the y values and then +2. And then we could plot those points there. So the square root function. Let's see if I can get this thing to let me zoom in a little bit more. The base function for a square root function is going to be the square root of x. And if we are unfamiliar with what this looks like, then we should make a table. Now, our table for the square root of x is going to be a little different. So the first thing is we know that we can't go negative. So I can't start at -2, -1 like we did with the parabola. I'm going to start at 0. And then I'll do 1. And then I'm not going to do 2 because if I do the square root of 2, that's not a nice number. Same thing with the square root of 3. But 4 is. So I'm going to do 4 as my other x value for my basic table here. The square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. So this gives me nice, good, clean things that I can work with. And when I plot them, I have a point here at 0, 0, 1, 1, and then 1, 2, 3, 4, up 2. Okay? And that's going to be what a square root graph looks like. And it actually is, coincidentally enough, kind of like a sideways parabola. If we were to just continue it going this way and turn your paper sideways, that's x squared. And that's not a coincidence. That has very much to do with a lot of things that we'll learn about later on in the school year, something called inverses, things like that. But if we had left that bottom piece there, it wouldn't be a function. And that bottom piece is actually what the negative square root of x would be. So if we did both a plus and minus square root of x, it actually makes this sideways looking parabola. So it's kind of a neat little connection to what we were doing. So let's talk about its main properties then. All right, so we're going to start off. Last time we described the parabola as a U. So I'm going to refer to this as the top of a sideways U. How do you spell sideways? Man, sideways U, right? So that's what we got going on, right? It's the top half of a sideways U because it doesn't have the bottom half. I'm going to put this part in quotes, starts, okay? It doesn't necessarily start, but what I mean by that is this kind of point right here where things kind of, begin. So it starts by default at 0, 0. And again, that's going to be really important for us, just like the parabola's vertex, this kind of, quote, starting point. It can only be moved by translations. Reflections, stretches, and shrinks, so dilations, they're not going to change anything about that point. So that's like a nice point for us to be able to find easily. There is no symmetry in this one. Anywhere, no which way. Not just no y-axis, no origin, there is no symmetry. Our domain, we actually already know this because this is a square root function and we know that the inside x has to be greater than or equal to 0. So we could write it that way, or we could do 0 to infinity. Same idea if we have transformations now, since we know that by default its x is greater than 0, If we apply transformations to that, we'll be able to figure out what the domain is without having to do a lot of extra work. Similarly with the range, if we're looking at this, we can see that it is above the axis, and that is because it is impossible for a square root to ever equal a negative number. It's not possible. All right, so our range is going to be that y is greater than or equal to 0. Same idea, it's 0 to infinity. Square bracket there. If we want to talk about our shortcut graphing real quick, what we would do is, again, kind of start off by finding this start point. So we'd find the quote-unquote start, which is going to be what the translations are. So if we move left, right, up, or down, that's going to be where the start is. And then from there, we're going to follow a pattern. And the pattern is super similar to what we did for the parabola, but kind of the opposite, okay? Actually, you know what? Let's not do it opposite. Let's keep it going the way that we were doing, where we said we went over 1, and what we're going to do is go up the square root of 1. I think that that kind of resonated with some of you when we did that in class. So if we go over 2, that's not going to work nice. Over 3, not going to work nice. Over 4 is going to work nice. We're going to go up the square root of 4, aka 2. All right? What I was going to say is that you can think of this as an opposite of like a parabola. So if we were to say, hey, if I go up 1, I'm going to go over 1 squared. If I go up 2, I'll go over 4. So you can kind of like flip your ups and overs from the x squared graph if you wanted to. If that confused you, ignore that I said anything to begin with. So we're going to, first I will draw it using the shortcut for you, and then we'll talk about the real way of doing it, which uses the tables and applies the transformations. So first, let's discuss those transformations. There is a vertical reflection because of the negative sign that is on the outside of the square root, okay? So outside values, things that are here and things that are here. Inside values are going to be things that are inside the square root. So we have a vertical reflection, and our second main set of transformations is that plus 4 is telling us to actually go left 4, and then we're going down 1. So using that, I'm going to go left 4, 1, 2, 3, 4, down 1. So I'm going to use my shortcut right now. What that vertical reflection is going to do is instead of going up, I'm going to end up going down. So my first point is going to be over 1, up the square root of 1, so up 1. I'm going to count over 1, 2, 3, 4, and not actually put those dots there because that might be confusing. And then I'm going to go down the square root of 4, which is going to be here. If I were to go out 9 places, which is the next nice square root, 1, 2, 3, 4, 5 is 9, I would go down 3 from that starting point. So this is going to be what the square root graph is going to look like. And I can do that really quickly by kind of building the function from that starting point, by kind of applying transformations as I go. If you hated that still, then you're in luck. We're going to do it the real way right now. So I'm going to use the same table. So for square root, that's going to be x values of 0, 1, and 4. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2. And then I'm going to build these transformations. So I'm going to do x minus 4 because x is a jerk and the opposite of what it says. And then I'm going to do a negative y minus 1. So what's important here is that the y value is everything that's the square root part. Okay, so we have a negative square root minus 1, and y is the square root. All right, so a negative square root minus 1, a negative y minus 1. Hope that kind of makes sense to you. So now I can just apply these things. So I'm going to do the x value of 0 minus 4, 1 minus 4, and then 4 minus 4. Then I'm going to do negative y minus 1 for all of the y values over here. So negative 0 minus 1. This is going to be my start point because it always translates directly over. I'm going to do negative 1 minus 1, so that's negative 2. And then I'm going to do negative 2. And that's going to be negative 3. And if I look at the points that I plotted way over here, I'm at 4, negative 1 was my start point. I'm at 1, 2, 3, down 2. And I'm at 0, 3. So the shortcut lines up with the longer way. The longer way is perfectly fine. You just got to get fast at doing it, okay? So if you want to keep doing the table way, great. Do it 100%. Like, I support you. You got it. But you just got to be able to do it fast, okay? All right, we have a your turn. I would suggest that you pause the video and try the your turn yourself right now. What if I played like Disney music right now? But we get copyright strike on YouTube, and so I can't actually do that. But like, a whole new world. No, don't want me singing. All right. You should have paused the video. Now you should be watching it to go over what the answer is. All right. So if we're doing this thing has both a vertical reflection and a horizontal reflection. Okay, so that's a reflection over the x-axis and a reflection over the y-axis. Its starting point would still be at 0, 0. And now instead of going over right and then up, I'm actually going to go left and down. So I'm going to go left 1 and down the square root of 1. I'm going to go left 1, 2, 3, 4 and down the square root of 4. And then I would have gone left 9 and then down 3, but that's going to be off the graph. And so there are the 3 points that I'm required to graph for this. If we're using the table, okay, so we got table, 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 table. It's the same table that we used before. And when we apply our transformations to it, it's going to be a negative x and a negative y. So that doesn't affect 0, 0. That's why our starting point stayed the way it was. It's now negative 1, and now negative 4, negative 2. So we get the exact same points using the table as we get using the shortcut. Shortcut's just a little bit faster if you can handle it. All right. So what you got here is optional practice. You can feel free to do this. I'm not going to check it. I would suggest that you try 3A and B. It's kind of building what this would look like. So maybe I'll do one of them with you right now. We have the shape of a quadratic function. So right there, that tells us that x squared is our base thing. It's been reflected about the x-axis. So that's a vertical reflection when we're going across the x-axis because we're going up and down. Moving 3 to the left and 7 up. So if I were to write this function, that's going to be f of x. I'm going to have a negative to take care of the vertical reflection. I'm going to do a parentheses squared. That's me saying this is a quadratic function. If it had said a square root function, I would have done something like a negative square root. The 3 units to the left, that's going to actually be x plus 7. Left is a negative direction, and I'm going to do the opposite, plus 7. And inside, because left is an inside thing, affects x. And then 7 units upwards, I would just do, oh, I can't read. My bad. My bad. 3 units to the left, whew, and then plus 7 on the outside. Whew, reading, that's real tough. All right, if you want to try B, you totally can. It's the square root. Same idea, you just got to pay attention. It has a horizontal stretch. That's, a little bit harder, but I think you got it. And what we should do now is continue on into this page. So page 6-9, trying to zoom in on it, and we will start, I'm going to skip the warm-up and jump right to doing cubic, and then cube root, and so on. And hopefully I'll talk a little bit faster or something, because I feel like this is a long video already, and I don't want it to be. So if we're doing a cubic function, that's going to be an x to the third. And if we don't know what that looks like, we make a table of values. Table of values is going to start really similar with the x values are just going to go -2 to 2, but our y value is now x to the third. So I'm going to do -2 to the third. That gives me -8. -1 to the third is -1. 0 to the third is 0. 1 to the third is 1. And 2 to the third is 8. So these would be my points. If I came over here, I'm going to have 0, 0. 1, 1, -1, 1, and then I would be kind of off the graph, but I just want to show you that it kind of goes up really fast. Okay, so it kind of has this like little S type feel to it, like a little wobble that's happening in it. And that's really important. It's not just a straight line like that. It has like this kind of bend in it. All right, so that's important. If we're describing this in the same 5 bullet points we've been doing, the first one is kind of what it looks like. And that's a little confusing for me to describe, I think, but it's going to be like the, let's think here, the left side of an upside down U. So if there's like a U shape right here, it's the left side of that. And then the other one would be the right side of an upward shaped U. So that's kind of the 2 pieces. It's kind of, yeah, one side of an upside down U and one side of a right side up. So I'm going to say left side of, I'm just going to draw an upside down U, and then I'm going to do right side of an upside down one. Okay, So I think that's just the easiest way I can describe that one for you, or like it has the wobble in it, which is kind of like that little turn, twisty turn that it kind of does there. I'm going to put this in quotes and say that it has a middle point. This is going to be like our starting point, and that is at 0, 0. So they don't have vertexes, they don't have start points or anything like that, but we can kind of think of this point in the middle as being where we're going to start graphing always, because that's, again, the point that can only be moved by translations and doesn't get affected by horizontal stretches and shrinks, so dilations, or reflections. So that's going to be our best friend when we're trying to graph. This thing does have symmetry. It has origin symmetry. It is an odd function by default. So I'm just going to say that. And domain, we actually already know because this is a polynomial. X to the third is just a polynomial. So that's all real numbers, which we can write in either way that you want to write it. And our range we'll use just by looking at this graph. It is also going to be all real numbers because we're going up and down forever and ever in both directions. If we're talking about our shortcut, so we're going to, again, find this middle point or this starting point, which is the thing that is affected by the translations. And it's a little harder to do, I think, but same idea. We're going to go over 1, and then we're going to go up 1 to the third. And then I would go over 2, so over 2, and I would go up 2 to the third. Now what I also need to do is, in addition to going over 1 and up 1 in that direction, I need to go over the same and down the same. Okay, so I would go over 2 this way and down 2 to the third that way. So that's our shortcut. So we basically just have to remember, oh, x to the third is odd. So just like when we were doing x squared, we could use its symmetry and kind of go side to side. We're going to kind of go to the side but down instead of up, or up instead of down. Okay, so that's kind of its shortcut. If we look at this example, I'm going to list what the transformations are. So we have a vertical shrink, okay, on the outside by that factor of 2. So that's this part right here is the vertical shrink. Our inside is going to be the things that are inside the cube. Okay, so that's going to be the x minus 2 is inside and the plus 1 is outside. So that's going to give us a right 2 places and a up 1 place. If we're using the shortcut, I'm going to start with that actually. So I'm going to go right 2 and up 1. This is where the middle point is going to end up being. And what I would normally do is go over 1 and up 1 to the third, so up 1, but I'm going to cut that in half. So I'm only going to go up a half from there. When I go over 2, I would normally do 2 to the third. 2 to the third is 8. I'm only going to do half of that. So I'm going to go up 1, 2, 3, 4. And then I'm just going to mirror that the other way. So I'm going to go backwards and down, and then backwards 2 and down 1, 2, 3, 4. Okay, so using the shortcut, that's what we got going on there. Not the best at drawing on an iPad, nice and clear, so like the wobble's a little bit not perfect. If you want to see it a little bit better than that, you can check out my answer key in Schoology. If we go to do the table, we're going to do the same exact idea we've been doing. So I'm going to start with the basic table that just goes like this. So -8, -1, 0, 1, 8, and I'm just going to apply the transformations to it. So x is going to be x plus 2. That's going to make me move to the right 2 places. The y value is going to be 1/2 times y, and then plus 1. And that's because, again, just like before, the entire cube is what y is. So this is 1/2 the cube plus 1, so that's 1/2 y plus 1. All right, if we go to make the table, you're going to make me do basic math here. I'm going to probably cheat and try to look at my answer key so I don't have to do the math as much because, you know, math. 0, 1, 2, 3, 4. Again, all I'm doing is taking this column over here and just adding 2 to it. I'm going to do the same thing with the next one. I'm going to take that -8, cut it in half, add 1. That's going to give me -3. The -1, cut it in half, plus 1. I'm going to get positive 1/2. I'm going to get 1. This is my middle point. 1.5 or 3/2, and then 5. And if we were to look at all of the points that we have, here is 0, -3. Here is our 1/2, our 2, 1, our 3 and 1.5, and then way up here we have 4, 5. So our table lines up perfectly with our little shortcut, and we know that everything worked out. Here's your turn. You should pause the video now, and you should try it on your own. How'd that go? Was it easy? All right, you probably didn't even pause the video. I don't know if I can trust you. Bunch of hooligans, right? All right. We have a vertical reflection because we have that lovely negative sign outside of the cube. And then we also have a left 1 and a down 2. So I'm going to do the shortcut and then we'll do the real way. All right, so left 1 and down 2. This is where my middle point would be. When I go to do the vertical reflection, instead of going up, I'm just going to go down. So when I go over 1, instead of going up 1 to the third, I'm going to go down 1 to the third. When I go over 2, instead of going up 2 to the third, I would go down 2 to the third. So that's going to be way off the graph. And then I'm going to use symmetry. So this one I would go up 1 instead. And when I go over 2, I would go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. And there's going to be our points. We will connect the dots and again try to get that little wobbly kind of turn in there. Definitely not a straight line through all of these things. And that's it using the shortcut. Doing the real way, we're going to make our table. Ooh, I feel like I should just be copying and pasting this table at this point. Don't you think that we should just do that? Wouldn't it be cool if you could do that on your paper? Maybe someday. X minus 1 is going to be your transformation. That's the left one. Our y value is going to be negative y minus 2. And again, that's because the entire cube is what y is. So we're doing negative y minus 2. And we're just going to apply this to the table. So that's going to give me negative 3, negative 2, negative 1, 0, 1. And then let's see, this is going to be 6 because negative 8 is going to become positive 8 minus 2. Then we get negative 1, negative 2, negative 3, and then this one's going to be negative 10. And again, this is our little middle point, just so we know. And that lines up with perfectly what our graph is. There you go. That is the cubic function. Whew. All right. Feel like we're going slow still. Trying to go a little bit faster for you. We got the cube root function, all right? So this is not a polynomial, it is not a square root, and it is not a rational. So it's its own class of function altogether. So we're going to start off by plotting points for it because we don't really know what exactly it looks like. And this time we're going to do something a little bit different. We need to pick numbers that have a nice cube root. So what we really want to do is think about numbers that are raised to the third power at first and what those equal. Okay, so if I were to do like 0 to the third, that's 0. I do 1 to the third, that's 1. 2 to the third is going to be 8. 3 to the third would be 27. I think 27 is a little too aggressive for us. So I think we start with a negative 8. Then I'll do that its cube root, right? Because that's what y is. It's going to be the cube root of the x values. It's just going to be negative 2. If I do the cube root of negative 1, that's going to be negative 1. If I do the cube root of 0, that's 0. So I'm basically reverse engineering what these things are up here, in case you aren't following along. So I'm now going to do 1 to the third would be 1, its cube root would be 1, and then if I did 2 to the third, that would be 8, and its cube root would be 2. Now, those of you whose brains are on really nicely here, that table is the reverse of this table. Okay, so if we look at this table right here and just switch the x's and y's, that's going to give us what's happening down here. So if you know the cube x to the third table really well, you can actually just reverse it and just say, okay, I'm going to let the y values be negative 2, negative 1, 0, 1, 2, and then my x values would end up being negative 8, negative 1, 0, 1, 8, basically just reversing what we did before. So that makes it a little bit easier to create that table a little bit faster if that's the way that you feel like you want to graph it. When we go to do this, we're going to plot those points. We got some that are off the graph, and this one creates kind of the same idea, but it's an elongated S kind of in the x direction, whereas this one was like an elongated S-ish type shape in the vertical. This one goes more horizontal, okay? And that is exactly how I would describe it in our first bullet point here. I would say this is an elongated, so a stretched S shape. Okay? Same idea as before. It has kind of a middle point. It's not really a middle point, but it kind of has a middle, and that's going to be the thing that's affected by translations only. That's going to be our best friend when we're trying to graph with the shortcut. This also has origin symmetry, so that's kind of cool that it has that as well. Let's think here. What do we got? We got domain. I started to write range, even though I said domain. Domain is going to be all real numbers for this. Cube roots or odd powered roots do not have any restrictions like even powered roots do. So like our square root is not allowed to go negative underneath. Cube roots don't have that problem. So domain is going to be all real numbers. And our range is also going to be all real numbers. A little hard to see from this graph, but these arrows that are kind of going out here and here, they are also going up and down forever and ever, just very slow compared to the way that this one was going up and down forever and ever. Okay, so it still happens. Our shortcut, super similar to all the other ones, right? So we're going to start at that middle point, the one that's affected by the translations, and then when we do this one, a little bit harder for us to figure things out. I personally do it the way I was going to teach you earlier, where I kind of switch the words around. So for this one, I'm kind of going over 1, up 1 to the third. I kind of will switch that, and I'm going to say, instead of over 1, I'm going to say up 1, and then I'm going to go over 1 to the third. That's how I do it, because I view the cube root as basically something to the third, and so I kind of keep it going that way. So just to kind of explain that again, what I would do is actually go up first. So I would say up 1, and then I say go over 1 to the third. That's my preferred way of doing it, and I would go up 2, and then I would go over 2 to the third. If you don't like it that way, then what you would have to do is, to be more consistent with the way we've been doing it, you would say that you're going to go over 1, which works perfectly fine, but you're going to go up the cube root of 1. You would have to then say, well, over 2 is not a nice cube root. Over 3 is not, going to be a nice cube root. 4, 5, 6, 7, 8. You would have to go over 8 in order to go up a cube root of 8. So I just think it's a little bit easier to reverse my ups and overs and kind of treat this like it's still to the third instead of a cube root. Same idea in the long run, but just, different. Same but different. All right, here we have a vertical reflection. That's the negative sign that's chilling on the outside. And then we have a horizontal shrink or dilation by a factor of 2. Okay, so we're shrinking ourselves by 2. That's because this is inside, so anything that is inside the cube root is going to affect x. Anything that's outside is affecting y. When I go to graph this, it's going to be kind of a weird graph for us to maybe start off with, but oh well. There are no translations, so my middle point stays at 0, 0. Normally what I would be doing here is going over, I would go up 1 and then over 1 to the third, so I'm going to follow my kind of strategy here, but instead of up, I'm going to go down because I have a vertical reflection, and instead of over whatever I do, I'm actually going to cut that in half, right? So a shrink by 2 in the horizontal direction is going to change my halves. And BT dubs, a lot of people just stick to the table for cube roots because it's a little bit harder for a lot of people. So instead of up, I'm going down, and instead of over 1, I'm going to go over half. When I go down 2, instead of going over 2 to the third, I'm doing 2 to the third divided by 2, so that's going to be 4. So 1, 2, 3, 4. And I'm going to use symmetry to just mirror image this on the other side. So I'm going to end up with something like this, and there it is. Again, not great at drawing that on a smartboard, on an iPad, which is what I'm drawing on, but close enough. If we're doing the real table, the hardest part about this is that you have to memorize what the table is. So I personally do it by thinking of it like the reverse, x to the third. So I'm just going to flip and do my y values as -2, -1, 0, 1, 2. And I'm going to treat the x values like I'm doing y to the third is basically how I'm doing this. So -x, -1, 0, 1, and 8. When I apply the transformations, it's going to be an x divided by 2. I swear I changed to the color, but it didn't do that. So that's going to give me my horizontal shrink, and I'm just going to do a -y. Let's change the color for reals now. So that's going to be -4, -1/2, 0, 1/2, and 4. That lines up with all of my other points. This is just going to reverse those things around. My middle is still chilling right here. Alrighty, this is fun. Your turn. You should pause the video and you should try it yourself. How'd you do? Great, I hope. This thing is going left 2 and it's going up 5. If I'm doing the shortcut, that's what I'm going to start with. And so that's going to be right here. I'm going to be going up 1 and over 1 to the third, I'm going to go up 2, and then over 2 to the third. So that's going to be over 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm just going to mirror image that. This one's going to be off the graph. There is my elongated S shape. Whew, not the cleanest thing, but I feel like this video is long, and so I'm trying to hurry for you so that you aren't here forever. All right, so our new table is just going to be x minus 2 and y plus 5. Okay, so I'm just going to apply that to all these things. So negative 8 minus 2, negative 10. I'm hoping you get the idea of how this table is filling out here. If you don't, I suggest you ask someone in class, because my guess is that there is at least one person in there who does understand how I'm filling this table out, and they could definitely help you. If we match those points up, it's going to work perfectly. Whew. Last one, absolute value. You might have done absolute values before. Absolute values are kind of fun. Honestly, I don't use a table no matter what, even the long way. I just think that it is completely unnecessary, but I will show you what it would be if we're doing that y is the absolute value of x. We're just going to get 2, 1, 0, 1, 2. And if I go to graph this, it basically is going to create this really nice V shape, okay? Where these are straight line. Ooh, wow, totally missed that. Let's start there, go this way. All right, there we go. So there's our first thing. It is V-shaped. Fun, right? It has a vertex, so it officially does have a vertex at 0, 0. That is the thing that's going to move with translations. That's going to be how we'll do the shortcut. This thing does have symmetry. It has symmetry right now with the x-axis, the y-axis, which is going to be at x equals 0. So that will change depending on where the vertex ends up. The domain, which I think tricks people sometimes, the domain is actually all real numbers. X can be whatever we want. We can plug a negative x value in, it's just going to become positive. Our range is where things are going to change here. And it's going to be that y is greater than or equal to 0, which is going to be 0 to infinity if we're doing it that way. And again, we can figure out all of this stuff if we needed to without having to actually graph it. The shortcuts, really easy. We're going to start at the vertex. Okay, so we start at the vertex. Wow, the board is not writing very nice for me right now. Whew. And then what we can actually do is that these are lines. And if I look at these lines, this has a slope of +1, and this one has a slope of -1. So I can actually use that to my advantage and pay attention to what the slope would be, thinking about the fact that this is a line. And if I have something like m, absolute value of x, like plus b, I mean, I can basically, I don't want the plus b there. That's going to confuse you. I apologize. But let's do like m, absolute value of x. That's going to be a slope. And all I have to do is just recognize that with absolute values, I'm going to take that slope and do one of them in the positive direction and one with a negative of that slope. So I would do like m equals 1 in the positive x side, and I would do m equals -1 on the negative ones. Let's talk about that shortcut once we have this one, so we can see exactly how that is. So my transformations here are going to be left 2 and up 3, and I forgot, so that's the second one. The first one is that we have a vertical reflection. My bad, totally missed that at first. All I'm going to do for vertical reflections, instead of me kind of going up with my V shape, it's going to go down with the V shape. All right, so I'm going to start with the left 2 up 3 using my shortcut. And what my slope is kind of going to be here is kind of like a little -1. So if I go on the positive x side, I'm going to do that exact thing. I'm going to do a slope of -1, which is going to be all of these points right here. I'm just going down 1 over 1. And that's going to give me this side of the V. And then I'm going to do the opposite of that. So I'm going to do +1 on the other side, which is on the negative side of the vertex. Okay, so I kind of have a positive side of the vertex. So that's this side, the positive side. And then I have the negative side. So I just do exactly what the slope says, m equals -1. That's what's in front of the x value over here. And here I'm going to do the negative of that slope. And that's going to allow me to just really quickly, easily graph this. I strongly suggest you do it this way. It is the fastest way to graph it. If you don't want to do that, you can use the table. It takes so long. It takes so long to do the table this time. Here we go. We're going to do a x minus 2, and we're going to do a negative y plus 3. That would be what the table is. All right, so filling that in, that's negative 4, negative 3, negative 2, negative 1, 0, and then 1, 2, 3, 2, 1, and that's going to give us all of the first 5 points that we have there. Okay, so you totally can use the table just like before, but I really think that using this slopes and vertex is going to be much easier for you. So when I look at this, next one, oh, by the way, pause, do the your turn yourself. Totally believe that you're doing it. We're going to have a horizontal reflection, and we're going to talk about that for a second. We have a vertical stretch or vertical dilation of a factor of 2, okay? And then we're going down 4, all right? So let's talk about the horizontal reflection real quick. My graph is perfectly symmetrical to the line x equals 0. So if I have a horizontal reflection, it's not going to change. It's going to look exactly the same. So I can actually ignore that, and it's not going to do anything. The other thing I can do is just think about it. Okay, how do absolute values work? An absolute value of a negative is always just going to give me the positive because that's how absolute values work. So that's actually just the same thing as doing 2 absolute value of x minus 4, and I can basically ignore this as though it's not there. Using my shortcut, I'm going to go down 4 places, 1, 2, 3, 4. I'm not going to go over it all. And then this vertical stretch by 2, that's actually my slope. So I'm going to do slopes of plus or minus 2. So on the positive side of the vertex, I'm going to go up 2 over 1. So a slope of 2, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And on the negative side, I'm just going to do the negative slope of that. So negative 2 over 1. Okay, so there we go. And there is our V shape with a slope of positive 2 and a slope of negative 2. I can't emphasize enough that that is the fastest way to do absolute values. If you're feeling a little stuck on that, again, I strongly encourage you to ask someone in class, because my guess is that they might be able to explain it in a way that I can't via video. If we want to do this, officially what we're going to do is make the table. It's going to be a negative x. It's going to be 2y minus 4. And that's going to flip-flop all of the x values with their negative signs. And it's going to make this be 0, this be negative 2, this be negative 4, this be negative 2, and this be 0. And notice how, you know, the 2 and the 0 and the negative 2 and the 0, they have the same y values. That's why this whole horizontal reflection we can ignore, because it's not actually doing anything because of the way that the symmetry works. All right, that was the longest video in the history of the world. You do not have any homework, but if you would like to do the practice, you totally can. There's some practice here, some practice, and some more of the practice with writing the equations. Just pay attention to which type of function it is. Whew. I will see you next class. I hope you have a happy weekend. Okay, bye.